classifying things has always been a need. For instance, when we pair socks, we only group two socks if they are similar, that is, if they have the same class. We are able to tell if two socks form a pair just by looking at them. However, classification is not always that easy. Imagine that you are a doctor and based on some exams you have to decide whether a tumor is benign or malign. Such classification needs a detailed analysis considering various aspects of the tumor, such as its radius, perimeter, and area. However, just like socks, the tumor will have some things in common with other tumors. It is common sense that if a tumor is more like other tumors that are known to be benign than malign, chances are that it is probably benign. This example depicts the principle of the kNN algorithm. Given a sample with a number of features whose class is unknown, the kNN algorithm compares it with a set of other samples whose classes are known beforehand, the training set, and is able to classify it based on the found similarities. While the importance of the kNN algorithm is undeniable, as it is considered one of the most relevant algorithms of the last century, it is extremely demanding and requires significant computing power and energy. kNN's main bottleneck is the size of the data it operates. Usually, the training sets used by kNN are large, in the order of several gigabytes. Each time a new sample is given to kNN for classification, the entire training set has to be read out from memory, which has severe implications in the algorithm's performance and the system's energy consumption. Therefore, the two problems associated with kNN's execution that we aim to solve are its low performance due to the excessive data movements and its poor energy efficiency. The solution that we present, designated kNN-STUFF, consists of a system that leverages the properties of the technology and the kNN algorithm to mitigate these issues. kNN-STUFF targets a platform called System-on-Chip, or SoC, that incorporates both a general-purpose CPU and reconfigurable logic, and field-programmable gate array. In the reconfigurable logic there is one or several accelerators that execute the most time-consuming parts of the kNN algorithm. The lighter parts of kNN remain being processed by the CPU, which is also responsible for managing the accelerators. Field-programmable gate arrays are energy-efficient devices. Since the most intensive parts of kNN are executed in the reconfigurable logic of the SoC, energy efficiency increases significantly. Additionally, having several accelerators enables parallelism. Instead of classifying a new sample at a time, several samples are simultaneously classified. By doing so, the training set can be transferred simultaneously to all accelerators, reducing the number of times the dataset is read out from memory by the number of parallel classifications. Each accelerator locally stores a new sample for classification and processes an incoming stream corresponding to the kNN training set. In an earlier phase, the accelerator compares the sample with all the other samples in the training set by computing a distance metric. Then, it chooses the samples of the training set that are more like the sample being classified. Finally, based on the classes of the similar samples, the CPU assigns a class to the new sample. kNN-STUFF can be configured in several manners attending different requirements and system constraints, such as limited hardware resources. We demonstrate that kNN-STUFF provides speedups as high as 67.4 times when compared with a high-performance ARM Cortex-A9 while showing energy efficiency improvements higher than 50.6 times. These results were obtained in a SoC with an available reconfigurable area equivalent to a mid-size Xilinx Arctic 7 field-programmable gate array, showing the remarkable benefits of kNN-STUFF even for low-end devices. The advantages brought by kNN-STUFF enable the efficient execution of the kNN algorithm in a wide range of devices, from the elementary embedded system to the many-core cluster. In the era of the big data, where the processing and classification of monumental amounts of data are required, kNN-STUFF is an attractive alternative to classic approaches. kNN-STUFF is open source and very easy to use. Detailed documentation on how to configure and deploy kNN-STUFF is available on GitHub alongside some examples. The source code of kNN-STUFF is documented, organized and modular, making it easy to work with. We encourage extensions to kNN-STUFF and feedback is always appreciated.